Likhitha H. Welcome back to my YouTube channel. In today's video, you're going to see how to predict the age and gender of a person. So first, let me show you guys how does it look, how does our project look, and then let's move on. Yes, my age is between 11 to 14 or 15. So it's showing the right answer. So yeah, now let's see how to do this project. Let's begin the coding. So this is my reference file, so just ignore that, guys. First of all, we have to do the void reset.py. So let's do that. So first let's begin with the void reset. That is going to be the prediction part. So let me import the necessary libraries and I'm going to copy that from my reference file. The libraries, I'm going to copy it from my reference file. Yes. So first of all, we need the logging because we need to predict the faces, and then we need SYS, and then we have numpy for like the age and for the age calculations, and then we have for the model because we have to predict the age and gender, and then you have the input, activation, add, dense, flatten and dropout, all for the prediction. And then we have conversion of 2D. We have conversion of 2D because we need to predict the faces. First we need to know the faces, and for predicting the age and gender, it have to be in 2D form. So for that, and then averaging, pulling 2D, that's also for converting it to 2D. And then batch normalization, we have the L2, that's the regularizers. And then you have the Keras backend, that is going to be for the face thing. So let's begin now. First of all, we have to say sys dot set triggers. Yes, set recursion, and then I'm going to say sys set recursion limit because we have to set the limit of what the age should be. I'm going to set it to 2 into that means the 2 square of 20, and then we have the np dot random and random dot, let's put the seed up here, and then we're going to do 2 multiplied by 10 because we have to plot the seed over here. Yes. And then we're going to create a class called as void resnet. This is the class, and inside this let's create a function that is init function. You guys will know in a minute why should we use this. I'm gonna say self comma image underscore size comma depth. The image size we need it because what should be the face size, like in what place we have to keep it, and it predicts in which place for that. And then we need the depth. I'm setting the depth to 16. And then we need the k value for the backend here, for the Keras backend. So I'm going to set the k value to k. I'm going to set it to 8. The backend we have to set the k value to 8, and you guys will know in a minute. I'm going to say self dot depth, and I'm going to initialize all of them saying that self dot depth is depth, self dot image size is image, self dot k is k. So those I'm going to copy them. Yes, they're all here. Yeah, I'm going to say self dot depth is depth, self dot k is equal to k underscore k here, that's different. And then self dot drop out probability is 0 because we no need to drop out here. And then the weight decay, what should be the weight decay over here. And then you have use bias. The use bias we have set it to false, and then the weight in it is normal. These are the values. You guys will know in a minute why do we need it. And then I'm going to create, it's showing an error. I'm going to create a if condition saying if k dot image underscore data, it's here, it's good. If you put another thing like show image and all those things, underscore data underscore format is equal to th. This is the syntax that you have to do. If it's th, then logging dot debug of the image underscore data underscore format is equal to EF. We have set it to TF and TH. You guys will know in a minute what is this. And then I'm going to say self.channel underscore access underscore channel underscore access underscore channel underscore access is equal to -1 self.k undefined k is equal to k. This one, yes. Definition of line number 9, input k as the backend, yes. Redefinition of unused k from line. It's used right here, here. We have used it. I don't know why is it still showing. Let me run it and check. Yes, so there's no problem. And then we're gonna come down and we have to set the input shape. So I'm gonna say self dot input underscore shape. Remember the underscore before the input. Underscore shape is equal to the image size, whatever should be the face size. And then we are gonna say comma image size, that you guys will know in a minute. Image size comma 3, that we are gonna set it to 3. That's what we did. Here we have initialized image size and here we have set the image size. That's the difference. And sorry, else should come here. Yes. Oh, sorry. This is gonna be inside, and then we're gonna put the else. Logging.debug I'm gonna say image underscore data underscore format, because we have to format the image for predicting up, is equal to, we have set it again to TF over here. We have to set it to TF. If it's TH, then it's gonna come inside this, or else if it's TF, it's gonna come inside the else. And then we're gonna say self dot, here we're gonna call the channel access underscore channel access is 1. Here you remember guys, we have set it to -1, and here we have to set it to 1 because this is gonna be of TF and this is gonna be of TH. And then the input shape, we are gonna set it to 3 itself. The input shape in the sense the image size, we are gonna set it to 3 itself, comma 3. And then we have another function inside the class itself. So let me call that def underscore white basics. That's going to be the def underscore white basics. This is all going to be of the face, the prediction type and everything about that. So let me just do that and show it to you guys. Self comma n underscore input underscore plane. So this is going to be the features. Let me copy off all those features till here, till the for condition. Do not worry about the code. I'll be pasting it in the GitHub link below. Yes. Here the function is. This is going to be inside. And then this is going to come inside this. And this is going to be inside this. Yes. So first of all, we have created a function, and here as the features we have put self. That's the main, because we have to initialize them. And then the n input plane, the output plane, whatever should be the input and the output, and then we have the stride over here. And then we have the conversional parameters. That's going to be 3 the face size, and then stride as same. The same thing we have done. These conversional parameters are for the width and height, for the kernel size, kernel width and kernel height, and then the stride, vertical stride and the horizontal stride. If it's same or valid, that's what we did over here. This is going to be the kernel width, this is going to be the kernel height, stride is stride, vertical stride, and if it's same or valid, that's what we did in the conversional parameters. And then you have the bottleneck plane, that's the output plane over here. That's what we did here. And now we need to call the face, but before calling the face we need to do the real-time demo, because we have we have to predict what type of face and what is the gender and age. This is all about the front end. Yes, so these are going to be the predictions, and now let me copy the rest because this is all going to be of predictions. Let me copy them, and that's going to be easier. These are going to be easier. And after doing this function, inside the function we have a for loop saying if for I and v, here itself we have initialized, nowhere else we have used this I and v. In enumerate of the conversional parameters, this is going to be the feature in this for loop, that's going to be conversional parameters. And then we're going to say if I is equal to 0, do not worry. If I is equal to 0, and if I is equal to 0, then we have another if condition inside the if condition, that's I is equal to 0. We have another if condition. Inside the for, we have just said that this is going to be the two values, and we have initialized it inside the for itself. And again, we have set the if condition saying if I is 0, then we have another condition inside the if saying if n input plane, that is the input plane, is not equal to the output plane, whatever is the input is not equal to the output, then net. This is another variable that I have just created in here. Batch normalization of axis is equal to self. As I imported here, you can see the batch normalization, that's for used for the normalization of the prediction. And then we have set axis equal to self dot channel axis, that's going to be the phase axis, and then the net. So again we told net is equal to activation of ReLU and of net, and then converse con is equal to net, that is going to be the activation of ReLU. And if the n input plane is not equal to the n input, else if the n input plane is not equal to the n output plane, then this is going to be these things. Else, if that means if the n input plane is equal to the n output plane, then converse is equal to batch normalization of channel axis. We don't need to do this activation. We don't need to say that this is this. So, and then we have told activation ReLU of cons. That's the difference, conversations and net. And then we have said that cons is equal to conversion of 2D. Conversion of 2D in the sense we have converted whatever 3D our face is, that we have converted to 3D. And then we have the end bottleneck plane, that's the neck plane. And then we have the kernel size, whatever should be the kernel size, that we have set it over here, that's V0 and V1. And then strides of V, as I told you guys here, the strides we have to keep it, the vertical stride of the stride vertical and stride horizontal, so these are them. And then we have the kernel initializer, that's weight in it. And then we have for the kernel regularizer, we have the weight decay. And then we have set the use bias. Use bias we have set to self.use bias, that the self.use bias we have set it to true. We have set it to, yes, we have set it to true, the use bias we have set it to true. And then we have the cons. And then we have told if the n input plane is not equal to the n output plane, then we have set the shortcut to convert this phase into 2D, and then strides is going to be this stride. We have did it over here, we have initialized it here. And then the padding we have set it to same. I told you it's same or valid. And then we have the kernel initializer, that's weight in it, kernel regularizer, that's weight decay. And then you have the use bias. The use bias is of the net, that we have done it over here in the if else conditions. And then we have return, yeah, and then we have another else condition saying else shortcut is net. We have set here the conditions. In this, whatever net value is going to be, that's going to be inside the shortcut. And then we have return at the, we have added this converse and the shortcut. And then we have returned their value. And then we have another function, that's underscore layer. We have set, here the features we have set is self, that's the main. And we have the block, input plane, output plane, count and stride. Here stride, the input block and output is the main. And then we have created a function called S. And that for that the feature is going to be the net that we have done over here. Shortcut. That one, the net is in this function. whatever we did is in this def f function, the net is going to be block, input plane, output plane, stride, and then the net whatever we have initialized here. And then we have told for I in range, whatever I is 0, we have created a if condition, and in the for itself we have created the I. So here this is a different I. For I in the range of 2, an integer count plus 1. Count, we have put it here, somewhere here. If I put the count here, it's here you can see. It's a feature. Whatever is the count, we have put it plus 1. And it's going to be an integer because our age should be in an integer form. And then we have returned the net, whatever should be the age. We have returned f, the function. And then we have set def underscore and call underscore. This is another function. We have set the logging. Yes, we have set the logging debug as creating model because we have to create what we have to predict the age and gender. We have set the login debug to creating model, and then we have said assert of self.depth is -4 and the percentage of 6 is equal to 0. This is just kind of a formula, and then we have told n is equal to self depth minus 4 divided by 4. That means divided by 6. That means self.depth, we have subtracted it with 4, and then we did the percentage of 6 and we have set it to 0. And then we have set another value of n, that's self depth minus 4 divided by 6. Whatever the depth value is going to be, that we're going to subtract it by 4 and then divide it by 6. The value we're going to divide it by 6. And input is equal to input of shape, the input shape that's our face, whatever our face is going to be. And then we have told the n stages. This is going to be the stages over here. You guys will know it in a minute. We have told 16, 16 multiplied it with k. That's going to be the backend k. We have multiplied it with that k. And then we told 32 multiplied with k, 64 multiplied with k. This is going to be for the stages. We have to hold the stages right here. And then conversion of 1 is the conversion of 2D, because we have to convert our face to 2D for it to predict. And then filters is equal to n underscore stage of 0. This stage over here is going to be 0, that's 16. The kernel size is going to be 3,3, that whatever should be the size of the kernel. That one we have set it to 3 and 3 itself, the height and width. And strides we have set it to 1 and 1, the strides of horizontal and strides of vertical. The padding we have set it to same. And then we have set the kernel initializer as usual, the weight in it. And kernel regularizer to L2, that was the input over here, the regularizers input. The regularizers import. Yeah, that's L2 of the weight decay. And then use bias, that's true. The use bias is equal to self.use bias of inputs. And then block underscore fn is equal to wide basic. Whatever should be the width and height, that we have put it here. And then conversional 2, 3, 4. Here what we did was we have set the block fn, that's this, the wide basic. And then we have set the input plane, the output plane, we have set the strides, count, and then we have set the conversional of 1, 2 and 3. This is going to be the prediction, that's conversions. And then we have pool, that's average pooling 2D, that's we have to make our face to 2D. Pool size is going to be 8 and 8, the width and height. And strides to 1 and 1, that's the vertical and horizontal side. The padding is same, and it should not be set to valid. And then it's going to be ReLU, we have done it in the starting, what's ReLU. And then we have set flatten is equal to flatten of pool, the import flatten. And then we have predictions over here. We use the dens over here. Dens of units, and that's going to be of kernels. Kernel initializer, that is here, right here, the weight in it. And then use bias is self of use bias, that's true. And kernel regularization, kernel regularizer is weight decay, and the activation of it is softmax. Here you have different activations, but I have set it to softmax, and then you have flatten over here. We have done the same to prediction A. That's going to be the prediction of age, and that's going to be the prediction of gender. We've done the same thing, but here units is 2 and here units is 101. Because here you have the gender, you just have 2, that's male or female. In the age you have many, so I set the units to 101. Then model is equal to model, that means we have predicted it completely now. That means we told model is equal to model of inputs, and the inputs is equal to inputs, outputs is equal to prediction of G and prediction of age. Prediction of G is prediction of gender, predictions of A is prediction of age. And then we have returned the model. That's what we did while we are predicting. And now we have to come to the front end, that we have to import Keras itself. That we have to import Keras face over here. So let me just run this, and this should work. And now we have to do the real-time demo, that means the front end part. First of all, we have to import CV2 for recognizing the face. So I have to do import CV2. And we have to do many other imports, so let me copy them up. Here till here. First we have imported CV2. For the face recognition, and then we have OS that you guys will know. Then we have import sleep for predicting, and then we have numpy as NP. We have imported numpy because for the calculations of age and gender. And then we have arc parse, you guys will know this in a minute. We have imported wide resonant, the resonant that we have created here. That is a different import, and that's a library. And then you have get file, we have imported OS and random. Here we have imported it 2 times. Let me remove this. So we have completed a voice resonant, and I have renamed this as voice resonant. And now let's move to the real-time demo, and I've copied up everything over here. Let me explain what is there here to you guys. First of all, we have imported the necessary libraries. The necessary libraries that are needed, the libraries that are needed are CV2. These are like you use it for face things, like for detecting the face and all. We use for showing the color and everything, we use CV2. And then we have sleep because we have to wait for 5 seconds for them to get ready. For the user. And then we need numpy because for the calculations of age. And then we have argument parse. This is needed because you need the arguments over here. And then you imported voicelessnet because we need it. We need to do the predictions for that. And then we need get file because we need to get this wide resonance file. So and then we have imported OS and random because we need to get we have few randoms where we have used random over here. For that we need random, and then we've created a class, that's class CV. Do not worry about the code. The code will be pasted in the GitHub link below. And then you have class. We have created a class that's face CV. This is a complete class. We have used everything here other than the get arguments and main. So this is the main class, and then inside the class we have case path and weight path. That here we have pre-trained models already which are trained. That means we have few faces and few the age and everything. So we have put it inside case path and weight path. And then we have created a function called as def new __ new __. Here you have class CLS, and you have weight file is none. We don't need any weight file here. Depth we have set it to 16, width as 8, and the face size as 64. So here we need the face size because here we have the cropping of face size. If not this, then this. If it's not Hassat, this is like a object, you can say. If not Hassat, inside this we have put features like class, If we are saying if this is not equal to this, if this is not has that, then the features inside this we're going to use is class and instance. So we're going to say class dot instance is equal to superface. This is not going to be has set, so it's going to be class dot instance is equal to super. It's just a function kind of super, no worry about this. Super face say face CV and class, and then you told dot new class CLS. So we need, that means we are gonna say that class instance is equal to new class, and then we have returned this class instance CLS instance, and then we have def init. This is you need this function. This is the most important one. Here we have the features like self. We have set the depth to 16th, width to 8, and face size to 64. And then we told self dot face size is equal to face size. Here whatever is the face size, that's 64. And then self dot model is equal to net, the import, face size. What here the face size is 64. 64 depth is equal to depth is 16, and k is equal to width is 8, so k is equal to 8. So that's going to be the self model. And then model underscore dir, this is another kind of variable. Inside this what we have stored is os.path.join, os.get cwd. This is, we're gonna get the the predefined pre-trained models. There's a file of that. Let me go and show it to you guys. Yes, you have pre-trained models over here. I have called those and told dot replace this with this. That means we're gonna get the complete predefined models inside this model dir. And then we told f path is equal to get file. Here we have a file called as weights.18. We have weights.18.4.6.hdf5. This is a file of weights. We told f path is equal to get file, so we got this file, and then we told self dot wrn underscore weight underscore path. We have just told that this is this, and then self cache, the cache subdir. After this, it's going to be the cache subdir is equal to model dir. That means this path, the pre-trained models, is going to become inside cache subdir. And then we told self.model.load weights. That means we get the weights in the feature here is fpath. So we have got the file weight, and the feature we put inside the self model is fpath. And then we have another function called draw label. Here the class, we have features over here is class. This is the main, and then you have image, point, label, font is sv2. This is a type of font, sv2.font underscore Hershey underscore simplex. This is a type of font. And then we put font scale to 1, the thickness of font to 2. So after that we told inside the function, we told size. This is going to be for the label. Like we have to display the the age and the gender. So that's why we have created this function. So we have set the size to cv2.get text size. What is the text size? That one we have set. And then we told label, the label over here, whatever we want to display. And then the font, we got the font over here, the cv2 font Hershey simplex. And then font scale, we have set it to 1, so we have called as font scale. And thickness, we have set it to 2. And then we told x and y is equal to point. This x and y in the sense the width and height, you can say. And then we have set the x and y to point, and then we told cv2.get we have created a rectangle for the age and the gender to be seen. So inside that, let's see what we put. We put the image, the x and y minus size, whatever is the size of the face, and x and y, that means the point minus size, and we put comma and we told x plus size, that means whatever point size comma y we put, and then we put 25500, that means this is the color, And then we told cv2.fill, we fill the color. And then cv2.put text, here we're gonna put whatever the age and gender is. We have to put the age and gender here. So we put image, the label we're gonna put it after the prediction, label, point, font scale we have set all of them here. And then we put the color over here, 255, 255, 255, and the thickness have set it to 2. And then we have a function called as crop face. Here we have the features as self, image array, the section, margin we have set it to 40, the whatever should be the face of margin, and then size of face we have set it to 64. The size of face we have set it to 64. And then we have created image height and image width. That is going to be image array dot shape. Image array is just an array of images. It's just an array. Here we told that this image height and image width is going to be this array. The shape of the array. That means whatever is going to be the size. And then inside this we told if section is none, then section is equal to the 0 and 0 comma width and height. So here we have set here we need to create an empty list inside the section because we need the parameters of that. So I've created 0 and 0, and then we have image width and image height. And then we told x, y, w, h, the x and y, and then we told the width and height is equal to section. This is section. So we have got the section inside x, y, w, h. And then we told margin is equal to integer of minimum value of the weight and height. What is the minimum value? That one is going to be the margin multiplied by margin divided by 100. Whatever margin we have set here, 40 divided by 100. And then we told x underscore a is equal to x minus margin. Y underscore a is equal to y minus margin. Xb is equal to x plus w, that's going to be the width plus margin, and we have yb, that's y plus height plus margin. And then we have created a small if condition saying if x underscore a is going to be smaller than 0, then xb is equal to minimum of xb minus xa and the image width minus 1. So that's good. We have applied the same everywhere. If we have created a if for y underscore a, x underscore b, and y underscore b. And then we told crop is equal to image array because we need to crop the face and tell this is going to be the face. So I've told image array of ya to yb and yxa to xb. That's what we told is cropped. And then we told resized image. We have to resize the image to predict. So we told cv2.resize, we have cropped because we need to resize it. So I've called the cropped here, and then size we have set it to 64, the size, that means the face size. And interpolation is equal to cv2.interarea. And then we told resize image is equal to np.array resize image, whatever is here. And then we have returned the resize image. And then we have created a function called as detect face. Here we're going to do the prediction. We're going to detect from here. So here we told face cascade is equal to face cascade classifier. It's a classifier of gender. So we told self.casePath. The case path we have set it here. Here we have set it, you can see it's predefined faces. And then I told video capture is equal to cv2 video capture. We need to call the Keras face. So we have called the video capture over here for it to predict. And then we told while true. This is an infinite loop until we say press the escape key. We told if not video capture is open. If the video capture is not open, sleep for 5 seconds because they have to get ready. They have to show their face like this, right? So for that we have told sleep for 5 seconds, and then we told ret and frame. These are just two variables, ret and frame. Inside this we have put video capture dot read. That means we're gonna read whatever we have captured. And then we told gray is equal to, this is going to be the color. And then we told face is equal to face cascade detect multi-scale. Here we're gonna detect the multi-scale saying the color is going to be gray. the scale factor is going to be 1.2. Minimum neighbors over here. Here we need the neighbors, so minimum neighbors we have set it to 10, and minimum size is face size, that's 64. And then we told if face is not equal to empty, then face images is equal to np. This is just a placeholder for the crop. For the cropped face, this is just a placeholder. So we told np.empty length of faces, whatever the face's length is going to be, and we're going to say comma self.face size, that's 64, comma self.face size, that's 64, and here we have 3. This is going to be the value is going to be 3. We need to return here, right? So we have set it to 3. And then for I comma face, I is not used anywhere, but in the for we have created I. We told for I comma face is also created in for itself in enumerate, and the feature over here is going to be faces, face underscore image comma cropped is equal to self dot crop face. That means whatever we have to show, we have cropped that, and then we have put frame inside this. Face we have called, and margin we have set it to 40, and size is going to be face size, that's 64. And then we have called the XYWH is equal to crop. That means whatever we have cropped, whatever should be the size, that one we have put it into XYWH. And then we have created you guys remember we have created a rectangle for displaying the gender and the age. So inside that we're gonna put we're gonna put the data. So we're gonna say frame comma x comma y comma x plus width and y plus height, and the color we have set it here, and we have set the value to 2. So this is going to be the rectangle. That means we have put everything inside, and then we told face images is this. The face image is going to be this, and then we told if length of face images is greater than 0, that means whatever length we have of face, that means if it's not empty or we don't have any face, then results is equal to predict. So we told model.predict of face images. We're going to predict the face image, and predict gender is equal to results, and ages here you remember wide net, we have put the results. So we have called that results over here, and then predicted ages is equal to results dot ages dot flatten. So here inside the predicted ages, whatever results we got, we have flattened it, and now we have to put it inside, right? So we told label is equal to format of integer predicted ages, whatever ages we have, and if it's female, if predicted gender is going to be, if it's going to be greater than 0.5, then it's going to be female, or else it is going to be greater than it's going to be smaller than 0.5, then it's going to be male. And then we have printed this predicted ages and predicted gender, and then we created a if condition saying predicted gender is going to be, here we have just put it into groups, saying that if predicted gender is going to be smaller than 0.5, and if the predicted ages is going to be greater than 25, and predicted ages is going to be smaller than 30, then we're going to print hello and say that their age is going to be between 20 to 30. And we've done the same thing saying else if the gender is going to be if it's going to be smaller than 0.5, that means it's male, and predicted ages is going to be greater than 30 and smaller than 35, it comes in the group of 30 to 35. And then if their gender is going to be female, and their predicted ages, the age whatever we have predicted is going to be, it's going to be greater than 25 and smaller than 30, then we have printed that it comes in the group of 25 to 30. And we broke the loop, and then we told cap.release, that means we're going to release the results, and then we told we're going to destroy all the windows here, and then we drew the label, that's the function draw label. We've called the function here. We told fame face 0 and 1, and then the label. So we have put the predicted value inside the draw label. That means the rectangle. Else print no faces are there. Here it's gonna print no faces. And then we have told cv.I'm show Keras faces. So Keras faces here is going to be like a window where that's where we're gonna predict. And then we told video capture.release again because we called the Keras faces here. So we have destroyed all again, and then we've got the arguments. This is a function. This is the function get args. That means get arguments. The parser here, that means the argument parser. So we told the parser is equal to argument parse dot argument parser. The description over here is this script detects faces from webcam input. That means the web camera, and estimates age and gender for detected faces. For the detected faces, that means it's gonna detect. And then format class is equal to argument parsed and argument default help formatter. Here we're going to call the help formatter. And then we have added arguments here saying the depth, type, and the default we've set. And then we have returned the arguments. Here we told arguments is equal to parser dot parse arguments. We have returned the arguments. And then we have created a function main. This is the main one. We have told arguments is equal to get args. That means we're going to get the arguments. And then we told depth is equal to args dot depth. We have set the depth over here. We have set the depth, right, to 18 or something like that. And then width, we are going to set it to arguments dot width. We have set the width too. And then face is equal to face CV, depth is equal to depth, width is equal to width. We told face dot detect face. That means it's gonna detect whatever is our age and gender, and then it's gonna throw out that. We told if name underscore name is equal to if underscore name underscore is equal to underscore main underscore, then we're gonna run this complete thing. That's what we told. So now let me run it, and before that let me off my web camera. So yeah, now we know how to predict the age and gender. That's great. Thank you friends. Please do like, share, subscribe and comment below. Bye bye.